Hey there, my name is Jeff Fritz, and I'm going to be talking to my buddy Thomas here about Cleipnir.Flows and learning a little bit more about how we can build workflow and durability into our applications using this cool little package and framework that's available on GitHub. Hey, I've heard a little bit about Cleipnir.Flows. Can you tell me a little bit more about that? Show me how it works.
Yeah, definitely. And thank you for letting me present my project. I really appreciate it. So Cleipnir.Flows is a framework you can use to try and help you out with making your code more resilient against all kind of different issues that can arise when you just code like a normal C# and in a distributed setting. So, yeah.
Those resiliency challenges, you don't know when the network might go down, a microservice might stop responding, there's an error somewhere in the middle, a database doesn't respond quite the way you expect, and having that resiliency is always important, and you don't know you need it until you need it, right?
Yeah, exactly. Yeah, it's kind of like concurrency like that. You don't really know until it goes bad, and when you try and look at it, it disappears. But yeah, definitely in enterprise systems where you have a lot of data going through all the time, these issues will manifest themselves, and it's important and actually not that difficult when you have framework support to make a resilient code. And,
So we can do that with a normal ASP.NET application, is what I'm seeing. Can you show us a little bit about how that works?
Yeah, sure. Yeah, let's go into the code mode, and have a look. So I thought that we make it the best way to present this, or to introduce the concepts of resilient programming and the framework, would be to kind of like move up from just regular C# code and then look at the different issues and how you can solve them with the framework. So right now it's just I've implemented a method that actually handles order. And the flow is quite simple, right? We are communicating with a payment provider because we have to capture and reserve funds from a customer's credit card. We have like an external logistics service which is responsible for packaging and sending the products that was ordered. And finally, we have an email service which we are going to ask to send an order confirmation to the customer, also with the track and trace number that we got from a logistics service. So, yeah. Yeah, sure.
Nice, simple process. The 3 steps after I finish ordering my brand new kitchen gadget from the store. I'm going to give you my credit card information. But yeah, what happens if something doesn't run quite right? Maybe I don't have enough funds on my credit card, or you don't have enough kitchen gadgets in the warehouse there for the logistics folks to ship.
Yeah, so definitely that's some of the things that can go wrong, definitely, and that's kind of like we can actually for these kind of specific scenarios where, let's say, you don't have enough funds, if we're able to reach the payment provider and the payment provider gets back to us saying there's not enough funds, that's actually, a good situation. It's just normal exception handling or whichever. It's kind of like hidden in this example, but the idea would just be that we would throw an exception and we would fail the flow. But that's even in Cleipnir, that's kind of like just solve as you would normal with the kind of try catch, or if you wanted to return a status from the reserve payment provider or the reserve call. What's more to do with resilient programming is more this issue that arises if we, for instance, send a request to the payment provider but we don't get a response.
Mm-hmm.
In this kind of scenario, actually, if we get a timeout from the payment provider, it's actually an ambiguous situation because we don't know if it's received the request or not, or if it hasn't. And the normal approach we can use there is that we would retry calling. That's all we can do for the most part, right? Just retry until we eventually get through and the payment provider is up again. The issue that arises if we do that, though, is that is that if we have a service and we have this kind of exponential backup strategy and we use Poly framework to do this, and we still accepting requests coming in from the outside, then this process itself might actually be overloaded and run out of resources and go down. So you can have like a cascading failure if you just, you naively just staying in memory waiting for an external service to come up. And that, I guess, brings us to the first point you could say about the kind of like what resilient programming is about. Is kind of like we're changing the programming model or the kind of like the tools that the developer has in his tool set. So one thing you can do is if we imagine that, for instance, we have a circuit breaker pattern somewhere hidden inside this payment provider client, which can tell us if the service is down, then we could actually, using the framework, do something like this. You can do like this, actually. So this in the framework in Cleipnir would mean that if the service is down, I want to postpone, suspend the invocation and then start up again at 5 minutes. So we would free the resources that the process takes up during that time by using that. So that's kind of like a simple improvement you can already do today in your code just by, using the framework. But we'll get to some of the more, details of what can go wrong. But yeah, I guess the second thing that we can then talk about is that we have all these external services that can be down, right? It's kind of like transient failures. We have external failures to ourselves, and we handle that using backup strategies and retry. What happens if it's the process actually executing the workflow that goes down? In that situation, it's actually much more severe, you could say, for us. Because if we imagine, for instance, that we executed the first 3 lines of code here and then we crash, we would end up in a situation where we did a reservation on the customer's credit card. We would have shipped the products off to the customer, but we never capture the funds. We don't send an email confirmation either. So it's kind of like we have to put something in place in order for this not to happen. And it's actually more common these days. It's not only if there's a catastrophic failure in hardware that it can occur, it also can occur if you have a system with a lot of data going through and you do deployments, right? And I guess these days we do deployments quite often, right? So yeah, when we do deployments, we do restart and we actually induce this problem ourselves. So we have to do something more to solve this situation. Yeah. The next thing that comes to mind, I guess, when doing this is that you would think, okay, let's just restart the flow. If we halfway through crash, we'll just restart it from the top. This is, for instance, what you get from Hangfire if you use that. But it's also what the message queue systems do by default, right? We have like redelivery of messages until they're acknowledged, and we only acknowledge the message when the Hangfire is completed, right? So the question is, what happens if we just restart this flow if it crashed halfway through? And the answer is actually not a very good state either. So if we had the first 3 lines executed and we did a restart, we would actually generate a new GUID, which would mean that the payment provider wouldn't recognize that it's the same transaction that we're referring to. So it would reserve the funds again. We'd also ship the products again. Depending on the outcome, we would capture the funds again and send them second email.
Thomas, I only ordered 1 kitchen gadget, but you charged me twice and you shipped me 2 of them and only sent me 1 confirmation email. That doesn't make me a happy customer, right?
Yeah, exactly. Yeah, that's a crazy world. Yeah. And it's kind of like it's difficult from logs as well, right? To see what actually went wrong. It's kind of like you would just see that, oh, this is weird. We have like a half completed message. How can that make sense?
And as the developer who wrote this block of code, if I'm looking at that, I don't want to write a bunch of if-then statements around it that says, well, if we already, go double check, did we already charge for this? And
exactly.
that's where Sleipnir can help us, right?
Yeah, exactly. Yeah. So let's have a look at some of the abstractions that it provides. You can use something called an effect, which actually does this. I'm just write it like this, and we do it like this. So what effect means, it's I was thought a long time about what I should call it, and it's always naming is, I guess, the most difficult thing in computer software development. But the idea is kind of like you have a side effect and you're trying to capture it. So you're trying to tame the non-determinism, and you're doing that by capturing. So what this means is that if you already have a transaction ID from a previous run, then use that. Otherwise, invoke the method. So this is actually a method reference, right? And then after you've executed the method, then store that result for future use. So that means just this one line of code that we added now means that every time we do a restart, we'll use the same transaction ID. So we kind of like change non-determinism a bit like this. But you do not only have to use it for like in memory stuff. You can also use it for external calls to external systems. So we can also use effects here. Yes, effect of caption. So it ship products, and it can go like this, right? So this now means that if we already ship the products in a previous invocation, then we will skip this step, and we're also allowed to return the value, or the return value will flow through this method call. I just saw one thing that's quite nice, and also because some people they say, oh, you have labels here, why do we have to explicitly name the state? And it's actually not that difficult to get rid of this and to have more implicit capturing of effects. But one of the things that it does provide you is if we go over and we have if we have a situation where we would like to kind of like change the state. Let's say that the ship products call returned a timeout exception to us. That would kind of like leave us in a situation where we wouldn't know if the endpoint received our message or it didn't. And perhaps, I guess, hopefully this is very rare. I used to work in a bank where we also had to do these things with some of the backend systems that wasn't internal to us. And then you would maybe go and investigate, and maybe you find out, okay, actually, we didn't. That ship products what call or message was never received. So we can kind of like change it on the effect here, ensuring that that the exception that was thrown earlier is kind of like canceled out, and we can start from a fresh. We do re-invoke. You can also, if you want to, you can also as a look, you can also change the state if it actually went well. You can go ship products, and you can go new track and trace, and you can go, actually, I know it was ABC for something like that.
And that's great when you have the ability to call your shipping provider and ask them, hey, did you get the shipping notification for this product, whatever?
Yeah,
and they're able to say, yes, it's ABC 4521. You can give folks a nice web page on your system to push that transaction along.
Yes, exactly. Yeah. So that's kind of like why I've tried to go for these explicit labels on each, because it makes it kind of like when you look at the state, what's the state of this, it makes it a lot more intuitive to get your head around.
Absolutely.
But, yeah. So that's, yeah, sorry.
It gives us that domain specific language that our customer service folks, our operations folks can look at, and they can read, they can work with, and then
exactly.
We're all speaking the same language, talking about the process that, in this case, an order went through. Cool.
Yeah. Yeah. Awesome. Yeah. So this is kind of like the you could say the symbol the symbol flow, because it's like an in-memory synchronous process-to-process communication here, right? We get the response directly back to the process executing this workflow using HTTP or gRPC or whichever, right? And that's kind of like that makes it simple to implement this. However, we have another like big communication pattern that we use all over in enterprises these days, and that is like what I call the broker approach. We see it a lot in like message driven systems where you have a message queue, you send out a message and you get the kind of like response message or related message. You might get them on a completely different replica, right? And you have the same thing actually if you have webhooks like callbacks, because it goes through a load balancer. So you don't have the same kind. It's not that easy to I guess put the things back together again to map the request and the reply. And a big part of what I've been working on it is to also make that flows in that architecture simpler. And I've tried to write the same flow as before, but in a message-driven system. So we have again a transaction ID the same way as before, but then we have these commands that we're going to send out on the message queue using a bus. So you could use Rebus or mass transit, whatever service bus you like, or directly you could have an instance to like a specific bus. And the idea is that we send out the command and the bus, and then we know that there's a reply coming at some point, and we can just wait for it like this. So messages will just, depending on the situation, you can do it by hand. So you can, when receiving a message from the outside, you can deliver that message to the specific workflow in question. But that's also, I'm working on integrations with Rebus and the other service buses to make this automatic. So it would automatically, deliver the message to the right workflow instance. But as we see here, right, it's kind of like you reserve the funds, then you have the message just waiting for that funds reserved to be received. And then when that has happened, you go to the next, you ship the products and so on. So the flow is very similar to the other flow, despite actually being a very different kind of like the way that the reality works underneath is a lot different.
So this is cool. You're showing us how you're bringing in and using a service bus to make sure that those transactions are maintained, they're consistent, they're stable, and they're reliable because they're using a service bus to back them. If we were using that previous model to wrap up here, we could use and reference and store that data somewhere else, right? It looks like there's some database support that we could use for that. What databases are supported right now by the Cleipnir framework with that?
Yeah, so I've been working on the major SQL relational databases. So there's a integration, or you can use Postgres to store the data of the workflow. You can use SQL Server, and you can use MySQL. So they're all supported right now. I'm working on a Redis implementation as well, and also I'm looking into Mongo. But basically, it is possible that you could use a whole range of different databases in the long term. It's just a question of me having enough time, or somebody else who wants to join in and help them. But yeah.
So getting some more help, helping folks discover and check out the Cleipnir.Flows. Where can we find that on GitHub and learn more?
Yeah, so let me show you. So it's actually you can write you can go into GitHub and you can search for Cleipnir.Flows. You can also just type Cleipnir.net, and that will also bring you to the repository. Okay. So that's kind of like a getting started guide. It's fairly simple. You install a NuGet package, and you can follow the kind of like guide here. It's similar to what I actually just went through, all the different kind of constructs you have and tools. So yeah, it's simple to get started. And then please, try it out, or look at the code. Get involved. Reach out to me if you want to know more about how it works, or if you're interested in using it. Definitely, you can reach out on GitHub, or you can look me up on LinkedIn as well. Definitely.
That's great. Thank you so much for sharing about the Cleipnir.Flows. There's some really cool stuff here that I think we can learn from and use in other projects that don't need a full, huge messaging framework, but we can get in and do something simpler, smaller, and more direct with that very explicit workflow that you've shown us.
Nice. Mean a lot. Yeah. Thank you.